All right, today I'm going to talk about the transfer of energy. By waves. Specifically, microwaves. Today, most people have. If they don't have a microwave oven in their home, you have at least seen one. We didn't always used to have them, though. They were developed in the 1940s by an American engineer named Percy Spencer. Ooh, CER. Named Percy Spencer. He worked at Raytheon. During World War II, and they were working on developing better radar. And the story goes that one day Percy had a Hershey bar in his pocket, and he was walking past one of the components that he was working on called a magnetron, and it melted the chocolate bar in his pocket, and he thought, I wonder if this could be used for cooking. The components of a microwave are all basically the same. So even it doesn't matter how your microwave looks, they all have the same type of components. It starts with a high voltage. A high voltage power source. Our high voltage power source. The electricity passes through a transformer. It passes the electricity to the magnetron. And I'm writing them in the colors of their numbers. So the magnetron converts electricity into microwaves. So if you recall, we talked about how microwaves are on the electromagnetic spectrum. So it converts them into microwaves, and the microwaves are at 2,450 megahertz. The microwaves are then passed through the waveguide. Which does exactly what you'd think it does based on its name. It is a channel which directs the microwaves into the cooking chamber. Our cooking chamber is number 3. Our cooking chamber prevents the microwaves from escaping. Thank you. Prevents the microwaves from escaping the chamber. And even the mesh that is on the door's window the mesh that's on the door is smaller than the microwave length, so it cannot escape. So this cooking chamber is sealed. The microwaves just bounce around off of all of the walls, and that little mesh that is on the window of the door is small enough such that the microwaves cannot leave the chamber at all. All microwaves have a turntable, and when we did our experiment, I asked you guys to take the turntable out. They have a turntable. This is so it turns the food so it is evenly exposed to the waves bouncing around. So the turntable, it turns the food so it is evenly exposed. So it is evenly exposed to the waves bouncing around in the chamber. The waves even travel through the container and penetrate into the food. So that is why we have the turntable. And lastly, number 5. Microwaves produce heat within the food. But some people say, oh, microwaves cook food from the inside out. And that is not really true. They only penetrate 1 centimeter. So if the microwaves are only penetrating about 1 centimeter, how is the rest of the food cooked? The center of the food is cooked by conduction. We said conduction is the direct transfer of heat, moving from high heat to low heat. So heat moves from the parts that have been hit by the microwave and heated up throughout the food to areas where there is less heat. If you look at your bag of popcorn or frozen dinner containers, they have a layer of aluminum film within the packing. Can't spell this morning. They have a layer of aluminum film in the packaging. To help distribute the heat. But wait a minute, I can hear you all say. How is it these packages can have an aluminum film in them, but I can't put a fork in the microwave? The aluminum film is very uniform and very flat and is protected or insulated a little bit from direct exposure to the microwaves. The reason why we can't put metal directly into the microwave is because metal will act as an antenna. For the microwaves. It will draw the microwaves directly to it. And it will transform them back into electricity. Which is why it will spark. It causes giant, dangerous sparks, which will, at best, ruin your microwave. At worst, set everything on fire. So please do not put metal in your microwave oven. And so this is an example of how waves carry energy and we use them to cook food.